Hello everyone, this is Afzalur Rahman. In our today's class, we are going to discuss about the structural evidence of glucose. Okay. So in our last class, we have discussed about monosaccharides and its various example. There is aldoses and ketoses, and after that we have discussed about glucose, preparation of glucose, and then we have discussed about the structure of glucose. Okay. So in our today's class, we will be discussing about the structural evidence of glucose. Means in the structure of glucose. Okay, this is the structure of glucose, and in the structure of glucose, it contains one aldehyde group, 4,2-degree alcoholic group, and one primary alcoholic group. Okay, so how the presence of this group can be confirmed? Okay, so that we are going to study in our today's class. Okay, how is the presence of these aldehyde groups and 2-degree alcoholic groups and primary alcoholic groups can be confirmed? Okay, that we will do in our today's class. Okay, so let us start. So the structure of glucose, can be confirmed based on the following evidences. Okay, now first of all, you see number one. First of all, we know the molecular formula of glucose is C6H12O6. Okay, so first of all, molecular formula of glucose, we all know its formula is C6H12O6. Okay. Number two, straight chain. Okay, now means in the glucose, all these carbon atoms, they are in the straight chain form. So how it can be confirmed that this glucose, these carbons are in the straight chain form? Okay, so various tests can be, with the help of various tests we can confirm it. Okay, so first of all, number A, when this glucose is reduced with sodium amalgam, this sodium amalgam is a reducing agent. Okay, so when this glucose is reduced with sodium amalgam, it will give sorbitol. A hexahydric alcohol. And in the hexahydric alcohol, sorbitol, all the carbon atoms are in the straight chain form. Okay, which indicates that in glucose also these carbons are in the straight chain form. Okay, so by reducing this glucose with sodium amalgam, we can confirm that. Okay, this glucose in the structure of glucose, these carbons are in the straight chain form. Okay, I am writing the reaction here. You see. So here we can write glucose on reduction with NaHg, means sodium amalgam gives sorbitol. Okay, and this sorbitol is a hexahydric alcohol. Okay, so what will be the reaction? You see the reaction. So I am writing the reaction here. Okay, so here you see I am writing the reaction here. We know the structure of glucose is CHOH. Here we have 4 CHOH units. Okay, so you can write it like that. Okay, CHOH 4 times. Here we have CH2OH. Okay, now here you see we have 6 carbon. Here we have 4 carbon, 5, 6. Okay, so C6H12O6. So this is the structure of glucose. Now when this is treated with sodium amalgam, NaHg, sodium amalgam in presence of these 2. Okay, here we are reduction. Okay, now here you see when this glucose is treated with sodium amalgam, it will reduce this aldehyde group into alcohol. We know when alcohol is oxidized, it will give either aldehyde or ketone. Or when it is reduced, when this aldehyde or ketone is reduced, it will give alcohol. It will give alcohol. So here you see, here we have aldehyde group. Now when this glucose is reduced with sodium amalgam, it will reduce this CH2 group, this aldehyde group into alcohol. Means this CH2 group will be reduced to CH2H. It will reduce to CH2H, and we already know that aldehydes on reduction gives primary alcohol. Okay. So this CHO molecule will be converted into CH2OH. Okay. Here CH2OH. Here we have CHOH. 4 times, and here we have CH2OH. Okay. So here you see, this is a hexahydric alcohol, means it will contain 6 OH group, 4 OH, 5, 6. Okay. So its name is sorbitol. This sorbitol is a hexahydric alcohol, and this is glucose. Okay. Now many of you may think that how this CH2 group is converted into CH2H. Okay. Simple, you can see this CHO molecule. We can write it C double bond or bond H. Okay. This CHO molecule can be written like that. Okay. So this on reduction means addition of hydrogen. Suppose here we have two hydrogen. Okay. So this upon reduction, and reduction means addition of hydrogen is called reduction. So here you see, here in this C double bond O, we have two bonds. One is sigma bond, another one is pi bond. Okay. Now on reduction of this glucose molecule, okay, these two hydrogen will be added to this system. Okay, now this CH2 system, and it will convert into CH2H. Okay. How it will add? Here you see this pi bond. This pi bond is a weak bond, so this pi bond will break. Okay. And out of this two hydrogen, one hydrogen will be added to this one, and another hydrogen will be added to this one. Now you see, here we have CH2 bond OH. Here you see CH2 bond OH. Okay, so this is alcohol. So this is how this glucose on treatment with sodium amalgam or reduction with sodium amalgam gives sorbitol. Okay. Then B. Okay, with the help of another reaction, we will confirm that this glucose contains this carbon atom in the straight chain form. Okay, then glucose on treatment with hydrogen iodide and red phosphorus at 373 Kelvin gives a mixture of N-hexane and 2-iodohexane. Here you see this glucose upon treatment with hydrogen iodide and red phosphorus, it will convert into N-hexane, there is straight chain hexane, and 2-iodohexane. Okay, so here I am writing the reaction. Here you see, here the structure of glucose, CHO bond CHOH 4 times. Here we have CH2OH. This is glucose. This glucose upon reduction with hydrogen iodide and red phosphorus at 373 Kelvin. Okay. So this reaction we have studied in our class 11 also. Na? Any molecule, that is any alcoholic molecule, any carbonyl molecule, okay, na? This or carboxylic acid molecule on treatment with the hydrogen iodide and red phosphorus, it converted into corresponding alkane. It converted into corresponding alkane. Similarly, this glucose upon treatment with this hydrogen iodide and red phosphorus on reduction with that, okay, Okay, it will convert it into straight chain form, that is hexane form and to iodohexane. So here it will convert into CH3 bond CH2 bond CH2 CH2 bond CH2 bond CH3. Okay, so this is N hexane plus CH3 bond CH bond I bond CH2 bond CH2 bond CH2 bond CH3. Okay, so this is 2 iodohexane. 2 iodohexane. Okay, so this glucose upon treatment with the hydrogen iodide in red phosphorus, it converts into N-hexane. In N-hexane, all these carbons are in the straight chain form. All the carbons are in the straight chain form. And these 2 iodine hexane also, all these carbons are in the straight chain form. Means this reaction indicates that in the glucose unit also, all these carbons are in the straight chain form. Okay. So here you can write this reaction indicates that in glucose all the carbon atoms are in the straight chain form. Okay, so all these carbons are in the straight chain form. Okay, so you can write the reaction. Next you see number 2, presence of aldehyde group. Okay, this CH group. Okay, how the presence of this CH group can be confirmed? You see, with the help of different tests, we can confirm that this glucose contains an aldehyde group. Okay, so here you see this glucose on treatment with hydroxylamine and HCN, it will give oxime and cyanohydrin. Okay, so here I am writing the reaction. Can you see? Here we have CHO bond CHOH 4 times bond CH2OH. So this is the structure of glucose. So this glucose on treatment with hydroxylamine. The formula of hydroxylamine is NH2OH, and this also upon treatment with HCN. Okay, it will give defined product. Okay, so upon treatment with hydroxylamine, so this here you see this CHO, we can write C double bond H. Okay, so this glucose on treatment to hydroxylamine, it will form oxide. So here you see 1 molecule of H2 will be removed. Okay, so what we are getting, here you see CH, then double bond, then we are getting NOH, and below we have CHOH 4 times bond CH2OH. Okay, so this is called oxide. Or exactly you can say that this is glucose oxide. Okay, and now you see this glucose on treatment with HCN, it will form cyanohydrin. Okay, so how it will form? So here you see this is del minus, this is del plus, this is plus, this is minus. Okay, so this is plus. You see here this CN minus will attack this carbon, Okay, so the balance of this carbon will increase. So it will shift this pi bond towards oxygen. So it will become O minus. So this O minus will take this H plus. So it will become OH. It will become OH. Okay. So what we are getting, you see, here we have CH. Here we have CH bond. Here you see there will be only one bond. Okay. Bond O minus, and this O minus will take this H plus. So it will become OH. And here this Cn is attacking this carbon. So here we have Cn. Okay, and below that we have CH, OH, 4 times bond CH2, OH. This is called cyanohydrine. Or exactly you can say that glucose cyanohydrine. Okay. So you see, any carbonyl compounds, aldehydes or ketones, on treatment with hydroxylamine or HCN, they will form oxime or cyanohydrine. Okay. So similar to that of the reaction of aldehydes or ketones, this glucose also on treatment with hydroxylamine and hydrogen cyanide, it also forms oxime and cyanohydrine. So it indicates that this reaction indicates that this glucose contains a carbonyl group. Okay. So this reaction indicates that glucose contains a carbonyl group. Carbonyl means C double bond. Okay, C double bond. Now this carbonyl group may be aldehyde, may be ketone. Okay, na? So we are not confirmed about this whether this group is aldehyde or ketone. Okay, na? Just we have confirmed that in this glucose it contains a carbonyl group. Okay, na? And the presence of this aldehyde group can be confirmed in the next example, okay, or in next test. Okay. So the next reaction is, this is number 1, number A. Okay, na? This is glucose on treatment with the hydroxylamine and HCN, it will form glucose oxide and cyanohydrine. Number B, glucose on treatment with bromine water, tolerance reagent or failing solution forms gluconic acid. Okay. Now we are writing the reaction. So here you see CHO bond CHOH 4 times bond CH2OH. So this is glucose. Okay. So this glucose on treatment with bromine water Br2H2O or tolerance reagent or failing solution. Okay, this bromine water, tolerance reagent or failing solution, these are mild oxidizing agent. Okay. So it forms gluconic acid. Means this glucose on treatment with this mild oxidizing agent, it forms gluconic acid. Means here you see this aldehyde group will be oxidized to carboxylic acid. Okay. So here you see this CHO will be converted to COOH. Okay. The rest part will be same. Here we have CHOH 4 times bond CH2OH. Okay. Its name is gluconic acid. Okay. So this reaction confirms that in the glucose it contains an aldehyde group. Okay. then why not this ketonic group? Okay, now you see both these aldehydes and ketones, they can be converted into or oxidized to carboxylic acid, but this aldehyde upon oxidation is carboxylic acid with same number of carbon atoms, and this ketone also on oxidation gives carboxylic acid but with one carbon less, But here you see this glucose we are oxidizing, so it gives carboxylic acid, but with same number of carbon. Here you see in that we have 6 carbon, here also we have 6 carbon, so which confirms that in the glucose this carbonyl group is an aldehyde group. Okay, now here the number of carbon atom is same. Okay, which confirms that in glucose the carbonyl group is an aldehyde group. Okay. Okay. Next. Next you see number 3, treatment with acetic anhydride. Treatment with acetic anhydride. The formula of this acetic anhydride is CH3CO twice O. So this is acetic anhydride. Treatment with acetic anhydride. Okay, so this glucose on treatment with acetic anhydride, it forms a pentaacid, which indicates that in the glucose unit it contains 5 alcoholic groups. Okay, so I am writing the reaction here. You see glucose on treatment with acetic anhydride forms glucose pentaacetate. Okay, here you see the right reaction. CHO bond CH, OH bond CH, OH bond H, bond H, bond CH, OH bond H, bond CH, OH bond H, bond CH, okay. Okay, here we are writing in open form. Okay, so this one treatment with acetic anhydride. So the structure of acetic anhydride is CH3CO twice O. Okay, so it forms glucose pentaacetate. Okay, now you see this acetic anhydride, we can write it like that. Okay, CH3C double bond O, bond O, bond C double bond O, bond CH3. Okay, so here it is CH3CO. Here we have CH3CO 2 times. Here we have CH3CO. So CH3CO twice O. Okay, so what will happen? You see, so this suppose this is del minus, this is del plus. Okay, so here we have del minus, here we have del plus. So when you treat this molecule, okay, now, so it will this CH3C double bond O minus, this will take one H plus. Okay, now, so it will be removed as CH3C double bond O bond OH. CH3C double bond OH. Okay, so here we have taken 5 acetic anhydride. Okay, so from this structure, okay, now 5 hydrogen, 1 2 3 4 5. Okay, so 5 hydrogen molecule will be removed as 5 CH3C double OH. Okay, and this OCOCH3 molecule will be attached. Okay, so after the removal of this group, okay, what we are left with? We are left with OCOCH3. Similarly also here hydrogen will be removed. We are left with O, then COCH3. Here also, okay, na? So 5 from the 5 OH group, okay, na? 1 H plus will be removed. Okay, na? And this shortcut we can write CHO bond. Here we have CH bond O bond CO CH3 4 times, and the last one here you see CH2 bond O bond CO CH3. Okay, so here you see one acidic group and here we have 4 acidic group. Okay, so total 5 acidic. So its name is glucose pentacetate. Okay, so this reaction confirms that in glucose unit it contains 5 alcoholic group. Okay, so here we can write this reaction confirms that glucose contains 5 alcoholic groups. Okay, but we don't know that how many of these alcoholic groups are 2 degree alcoholic group or 2 degree alcoholic or 1 degree. Okay, so we will confirm that in our next reaction. Okay, now see next. Number 4, reaction with HNO3. Okay, nitric acid. Here presence of 1 degree alcoholic group. Okay, with the help of this test we can confirm that the presence of primary alcoholic group. Okay, so this glucose on treatment with hydrogen cyanide, nitric acid. Okay, now so I am writing the reaction here. You see here this glucose CHOH 4 times bond CH2OH. This upon treatment with HNO3, it will form COH bond CHOH 4 times bond COH. This glucose upon oxidation with HNO3 nitric acid it forms saccharic acid. So this is the glucose and this is saccharic acid, or it's called glucaric acid also. Okay, now another reaction is there. Okay, now suppose gluconic acid. Okay, the structure of this gluconic acid is COH bond CHOH 4 times bond CH2OH. Okay, this is gluconic acid. This is gluconic acid also upon oxidation with HNO3. It will give saccharic acid. Okay. So this reaction confirms that this glucose molecule it contains one primary alcoholic group. So how you can confirm this primary alcoholic group? You see here this glucose after oxidation, this aldehyde molecule will convert to carboxylic acid. This is sure, na? But here you see this primary alcoholic group, this also converted into carboxylic acid. Okay, here you see we know this alcoholic group can be converted to aldehydes or ketones, and this aldehydes or ketones can be converted to carboxylic acid. Okay, but when this aldehyde is oxidized to carboxylic acid, the carbon number remains same. But if it is a ketonic group, okay, the carbon number will be one carbon will be less. But here you see from glucose to saccharic acid, the number of carbon is same, which indicates that in the glucose this it it contains this alcoholic group is a primary alcohol group. Primary alcoholic group because the number of carbon atoms are same. Number of carbon atoms are same. Okay. Here similarly, from gluconic acid also, if we oxidize this with HNO3 nitric acid, it will convert into saccharic acid, having same number of carbon. Okay. So from this reaction, we can confirm that from the above reaction, we can confirm that glucose contains one primary alcoholic group. Primary alcoholic group. Okay, now. So here see this HNO3 cannot oxidize this CHOH group. CHOH group. Okay, now. Because all this CHOH group, these are 2 degree alcohol. 2 degree alcohol, and this 2 degree alcohol after oxidation they gives ketone, and this ketone they will further oxidize to carboxyl acid. And if they oxidize to carboxyl acid, the bond should be break. Okay, now. The bond will clip. Okay, now. So this HNO3 cannot oxidize this CHOH group. Okay, now. This 2 degree alcoholic group. So it will only oxidize this primary alcoholic group. Okay. So with the help of this reaction, we can confirm that in the glucose it contains one aldehyde groups. Okay, now. And 4 2 degree alcoholic groups and one primary alcoholic group. Okay. So far we have discussed about the structure of glucose. First of all, we have studied about the we have seen that the molecular formula of glucose is C6H12O6. Then we have studied about the straight chain form. This is glucose on treatment with sodium amalgam. It gives sorbitol, that is a hexahydric alcohol. Then this glucose on treatment with the hydrogen iodide and red phosphorus, it gives N-hexane and 2-iodohexane, which confirms that this glucose contains this, the carbons in the straight chain form. Okay. After that, the presence of aldehyde group means this glucose when treatment with hydroxylamine, it forms oxime, and on treatment with hydrogen cyanide, it forms cyanohydrate. Okay, now, which confirms that this glucose contains an aldehyde, a carbonyl group. Okay, now, and the presence of this aldehyde group was confirmed when this glucose was treated with bromine water, tolerance reagent or filling solution. It converts it into gluconic acid. It converts into gluconic acid, which indicates that in this glucose it contains an aldehyde group. Okay. After that, treatment with acetic anhydride. This glucose on treatment with acetic anhydride, it forms glucose pentaacetate, which indicates that in the glucose we have 5 alcoholic group. Okay. And after that, the presence of this primary alcoholic group, can be confirmed when this glucose is treated with HNO3 nitric acid or this gluconic acid is treated with nitric acid. Both of these molecules they convert into saccharic acid. Okay, which confirms that in the glucose it contains one primary alcoholic group. Okay. So for today's class, up to this, in our next class, we will continue with our next topic. Okay. Thank you everyone.